Anyone? Carson, Oscar, Leonardo, anyone? Mark? It's in your notes.
Is it something about the magnitude?
Okay, I'm ready. Please, please, please.
It's negative x.
We don't start with negative x, but that's okay.
Well, we'll start with x then. Well, x when x is greater than or equal to 0.
Very good, and that's the other one. Very good, awesome. So then I have 1 over x minus 1 over the absolute value of x must have two different options. How come? Of course, if this piece has two options, then this entire function has two options. Can anyone give us the first option? Derek?
Be 1 over negative x. Well, the whole equation, like 1 over x minus 1 over negative x.
So we're talking about the first one.
I'm sorry. 1 over x minus 1 over x.
Excellent. And then if what?
If x is greater than or equal to 0.
It's in the denominator. We cannot have it equal to 0.
Yeah.
Is that clear?
Yes.
Perfect. Can anyone give us the second option? Trey, would you give us the second option?
1 over x minus 1 over negative x. If
Perfect.
X is less than 0.
Perfect. Perfect. Great job. So we finally simplified the whole thing. Can anyone give us the top branch? Oscar?
Is the top branch 0?
Thank you very much. And the bottom? One apple plus one apple is? 2 apples. Very good. Only now I'm ready for the limit as x approaches 0 from the right. So then the limit of 1 over x minus 1 over the absolute value of x as x approaches 0 from the right. Do not drop the limit operator. If you drop the limit operator, I cannot give full credit. You can drop the limit operator when you apply it. So after you apply the limit operator, you can no longer write it. But before you apply it, you have to carry it on and on and on. Good. So then what function do I apply the limit from?
2 over x.
One more time.
I mean 0.
Right. We have to choose this one because it's x greater than 0. And the limit is?
0.
Excellent. Thank you, Jordan. Great job. So that's how we deal with absolute value. A lot of work, a lot of simplification. Please remember the absolute value, formal definition of the absolute value. Okay, questions?
So if it was coming from the left, then the answer would have been 2 over x?
So,
or it would have been 2 over x equals 0?
Yes, so let's write that here. So when x approaches 0 from the left, which function will I write?
2 over x.
Very good. And then the limit would have been?
0. No, does not exist.
Where?
How much? That's what I said. Please remember the graph of 1 over x. If you don't remember the graph of 1 over x as I kindly asked you to, You're not going to remember what this is.
Infinity?
Which one?
Negative infinity.
Very good. Which means that x equals 0 represents
A vertical asymptote.
Thank you very much. So please remember those graphs. Go back to the notes. Everything is posted. In case you missed anything, please, so we can move forward as a group. And I don't want to lose anyone. The precise definition of the limit. I'm looking at the time because all my clocks and even my okay, so I have 6 minutes left. Is that correct?
Yes.
Am I correct? Okay. I'm not going to be able to finish this, so you're not responsible for 2.4 for Tuesday. So the precise definition of the limit. Why do we need this? Well, this is the only proof in this class. Initially, it will sound and look very difficult. It really isn't. We are only going to look at linear functions. I'm only going to look at linear functions and not infinite limits. So the simplest possible example in the entire section. Okay, so it's the only proof in this class. You're not going to see another proof, but you're going to move on to next class and you will see proofs there. So this is the only proof in the class. We're going to use it only for the simplest possible functions, and I'm not going to even ask you to look at the infinite limits. Just a simple linear function. So what does this mean? What are we trying to do here? So I'm going to graph a function. I said linear, but right now I just use any function. So this is function f of x. This is a. And this is L. So I hope you agree that when we say that the limit as x approaches a from either side of f of x is what?
It's going to be L.
It's L, right?
Yep.
Now, the concept, I'm going to use some mathematical notation that I highly recommend because it cuts back on a lot of writing. And here are the symbols that we are going to use. The upside down A, I have not invented these. These are legitimate mathematical symbols. This upside down uppercase A stands for every, for any. This symbol, backwards uppercase E, there exists. This little E, if you want, backwards, such that. And one that I'm not going to use with this definition, but I highly recommend you know, the same thing but facing this way, belongs to. So we normally like to write x belongs to the interval, let's say 0, 2. And this is not part of this definition though. But these are very well known and common and used symbols. For every or any, there exists such that, and it belongs to. But again, this is not part of this. Okay, so I know I only have 2 minutes left, so I'm just going to write it, and I'm going to stop, and we're going to dissect it next time, and I'm going to explain you're not responsible for anything in 2.4 at this point. So here is the precise definition. So also two more symbols. Delta. This is a lowercase delta. This is the uppercase delta. And this is epsilon. So the precise definition of the limit, also known or the epsilon delta definition. We prefer to say epsilon delta definition because it's shorter than the precise definition of the limit. And here it is. Limit as x approaches a from f of x is L. This is the double equivalency symbol. This means this implies this, this implies this. For every epsilon positive, there exists a delta positive such that every time we pick an x close to a less than delta, this will imply the absolute value in f of x minus L less than epsilon. Nothing, it means nothing to you right now. It makes no sense. I will explain.